Hello everyone. Welcome to Springboot tutorial episode 15. In this video, I will walk you through the features of Springboot version 3.0. And I will also help you to understand the performance in Springboot version 3.0. Let's move on.
Springboot is a popular framework for building applications on top of the Java platform. It simplifies the process of creating standalone, production-ready Spring applications with minimal configuration. Developers can quickly bootstrap their projects and focus on writing business logic instead of spending time on boilerplate code. Before Springboot, setting up a new Spring application often involved configuring numerous XML files or Java annotations. This process could be time-consuming and error-prone. Springboot addresses this challenge by providing auto-configuration, which automatically configures your application based on the dependencies present on the class path. One of the key advantages of Springboot is its convention-over configuration approach. It promotes best practices and provides sensible defaults, allowing developers to get started quickly. For instance, Springboot automatically configures an embedded web server, such as Tomcat or Jetty, so you don't need to set it up manually. Springboot also integrates seamlessly with other Spring projects like Spring Data, Spring Security, and Spring Cloud, making it easy to build robust and scalable applications. Its extensive documentation and active community provide ample support and resources for developers. Springboot 3 introduces several new features and enhancements to further improve the developer experience and modernize the framework. Let's explore some of the key additions. Java 17 baseline. Springboot 3 requires Java 17 as the minimum version, aligning with the latest advancements in the Java ecosystem. Developers can now leverage the features and improvements introduced in Java 17 and beyond. GraalVM native image support. Springboot 3 introduces first-class support for building GraalVM native images. Native images offer significantly faster startup times and reduced memory consumption, making them ideal for cloud-native and serverless deployments. Observability enhancements. Springboot 3 enhances observability with improved integration with Micrometer, a vendor-neutral application monitoring facade. Developers can easily instrument their applications and collect metrics for monitoring and troubleshooting. Improved container images. Building and deploying Springboot applications as container images has become even easier with the introduction of a new goal in the Springboot Maven plugin and Gradle plugin. Java 17 is a significant release in the Java platform's evolution, bringing numerous language enhancements, performance improvements, and new APIs. By requiring Java 17 as the baseline, Springboot 3 empowers developers to leverage these advancements and build modern, efficient applications. One notable feature in Java 17 is the introduction of records. Records provide a concise syntax for declaring immutable data classes, reducing boilerplate code and improving code readability. Springboot 3 embraces records, allowing developers to use them seamlessly in their Spring applications. Another significant addition in Java 17 is the sealed classes and interfaces feature. Sealed classes restrict which other classes or interfaces can extend or implement them, providing better control over inheritance hierarchies and improving code maintainability. Furthermore, Java 17 introduces various performance optimizations, including improvements to the garbage collector and string operations. These enhancements contribute to the overall performance improvements observed in Springboot 3 applications. Let's illustrate the use of a new feature in Springboot 3 with a code example. We'll focus on the GraalVM native image support, which enables the creation of highly efficient and lightweight executables. Java at Springboot application, public class. My application, public static void main string args. Spring application.run, my application.class, args. To build a native image of this application, you can use the goal provided by the Springboot Maven plugin or Gradle plugin. /mvnw Springboot build image. This command will compile your application and its dependencies into a native executable. The resulting executable will have a significantly faster startup time and lower memory footprint compared to a traditional jar-based deployment. The code example above demonstrates the simplicity of building native images with Springboot 3. Developers can easily leverage this feature to optimize their applications for cloud-native and serverless environments. Section 5. Performance enhancements. Springboot 3 brings notable performance enhancements, contributing to faster application startup times, reduced memory consumption, and improved overall efficiency. These improvements are a result of various factors, including the adoption of Java 17, GraalVM native image support, and optimizations within the Spring framework itself. Java 17's performance optimizations, such as improved garbage collection and string operations, directly benefit Springboot 3 applications. Additionally, the framework has been optimized to leverage the latest advancements in the Java ecosystem. GraalVM native image support plays a crucial role in boosting performance. Native images compile Java bytecode into native machine code ahead of time, eliminating the need for a just-in-time or JIT compiler at runtime. This results in significantly faster startup times as the code is already optimized for the target platform. Furthermore, native images have a smaller memory footprint compared to traditional jar-based deployments. By statically linking only the necessary dependencies and eliminating the need for a JVM at runtime, native images consume fewer resources, making them ideal for resource-constrained environments. Section 6. Springboot's impact on development. The Spring framework has revolutionized Java application development since its inception, providing a comprehensive and well-defined programming model for building enterprise-grade applications. Springboot builds upon the success of the Spring framework, simplifying the development process and empowering developers to create production-ready applications with ease. One of the key impacts of Springboot is its ability to accelerate development cycles. By providing auto-configuration, sensible defaults, and a convention-over-configuration approach, Springboot eliminates the need for developers to write boilerplate code and configure complex infrastructure. This allows developers to focus on writing business logic and delivering value faster. Furthermore, Springboot promotes best practices and industry standards, ensuring that applications are built with maintainability, scalability, and security in mind. Its extensive documentation, active community, and wide adoption provide developers with ample support and resources. Section 7. The future of Springboot. Springboot continues to evolve and adapt to the ever-changing landscape of software development. The framework's future looks promising, with ongoing efforts to enhance its capabilities, improve performance, and embrace new technologies. One area of focus is the continued integration with cloud-native platforms and technologies. Springboot already provides excellent support for building and deploying applications to cloud environments like Kubernetes. Future releases are expected to further enhance this integration, making it even easier to develop and deploy cloud-native Springboot applications. Another area of exploration is the adoption of reactive programming paradigms. Springboot has already embraced reactive programming with Spring Web Flux, a reactive web framework. Future versions may see deeper integration of reactive principles throughout the framework, allowing developers to build highly responsive and scalable applications. Section 8. Conclusion. Springboot has become the de facto standard for building Spring applications, empowering developers to create production-ready applications with speed and efficiency. Its adoption of Java 17, GraalVM native image support, and other enhancements in Springboot 3 further solidify its position as a leading framework for modern application development. As the Spring framework continues to evolve, we can expect Springboot to remain at the forefront of innovation, providing developers with the tools and features they need to build cutting-edge applications that meet the demands of today's ever-changing technological landscape. Section 9. References: Springboot documentation, https://spring.io/projects/spring-boot, Java 17 documentation, https://docs.oracle.com/n/javac/javac/1/7/docs/ap/index.html, GraalVM documentation, https://www.graalvm.org/docs/